Okay, we're starting geometry section 3.1 today, and just so you know, I'm sitting on my deck, but if the dogs start barking, that's why. You can hear it. Okay, so we're going to be talking about properties of parallel lines, and we're going to begin doing some proofs in this chapter. Not the paragraph proofs, but 2 column proofs. So first of all, we need to understand what a few of these angles are called. Here I have a picture of 2 lines, L and M, that are being intersected by another line, T. Line T is called a transversal, which is a line that intersects 2 coplanar lines in 2 different points. So I've numbered the angles around the intersection points. Here, something to write with. Okay, here is one of the intersection places where I've got 4 angles, 1, 3, 6, and 5, and then down at the bottom, angles 4, 2, 7, and 8. So where they intersect, they make these different angles. There's nothing special about lines L and M. In some of our other examples and some of the theorems, we will have L and M being parallel, but they're not in this case. So the angles that I have in red, number 1 and angles number 1 and 2, are called alternate interior angles. So when these angles are named, they're named for their position around with the transversal and the line that it's intersecting, like where it is in relation to those lines. So angle 1 is on one side of the transversal, angle 2 is on the other side of the transversal. That's where we get the word alternate. And then they're also inside the lines L and M, so they're on the interior of those lines. So the alternate comes from being on either side of the transversal, different sides, and the interior comes from being inside the lines L and M and not on the exterior. Okay, so those angle 1 and angle 2 are alternate interior. Can you find one more pair of alternate interior angles in this picture? Okay, angles 3 and angle 4 are also alternate interior angles because they're on opposite sides of the transversal and they're inside lines L and M. Okay, angle 1 and angle 4. Angle 1 is still in red, angle 4 is in green. This time, those are called same side interior angles. They're still inside lines L and M, but this time they're on the same side of the transversal. So that's why they're called same side interior angles. What other 2 angles would be also same side interior angles? Okay, angles 3 and angle 2. Those 2 are on the same side of the transversal and they're inside lines L and M. Okay, finally, angle 1 and angle 7, which is in purple, those are called corresponding angles. That means they're in the same position relative to the transversal T and the line that it's intersecting, whether that's line L or line M. So notice that 7 is on the left side of the transversal and underneath line M, and angle 1 is also on the left side of the transversal underneath line L. So name another pair of corresponding angles. How about 6 and 2? 6 is on the right side of the transversal and above line L. 2 is on the right side of the transversal and above line M. We could also choose 5 and 4 or 3 and 8. So there are 4 pairs of corresponding angles. Okay, so here's our first postulate for this section, postulate 3.1. The name is the corresponding angles postulate. This says if a transversal intersects 2 parallel lines, then corresponding angles are congruent. So in my picture, I have lines L and M being intersected by a transversal T. The red arrowheads on the lines mean that these 2 lines are parallel. That's how you mark that those two lines are parallel. So this one is different than the picture we just saw because in the other picture, L and M were not parallel. So if they are parallel and the transversal intersects them, then anywhere I can find two corresponding angles, then those two angles have to be congruent. In this case, the angles that we're looking at are angles 1 and 2. I could also have another pair. Let's say that's 3 and this is 4. Now, 3 and 4 are also corresponding angles because they're in the same position relative to the transversal and the line that's being intersected. So it's on the left side. 3 is on the left side of the transversal and above line L. 4 is on the left side of the transversal and above line M. So angle 3 would also be congruent to angle 4. Anywhere we could find two corresponding angles, we could say that they were congruent according to this postulate. Okay, after postulate 3.1, there are two theorems, theorem 3.1 and theorem 3.2. Both of these are going to be looking at the picture that's drawn in the middle. So the first one is the alternate interior angles theorem. This says if a transversal intersects two parallel lines, then alternate interior angles are congruent. So in this case, the alternate interior angles would be angle 1 and angle 3. Remember, the alternate interior angles have to be inside the two lines, so it's inside lines A and B. These two are. And they're on opposite sides of the transversal. So the alternate interior angles theorem says that these two angles are congruent. That only works if A and B are parallel. If the lines aren't parallel, then we can't use these theorems. Okay, the second theorem is called the same side interior angles theorem. It says if a transversal intersects two parallel lines, then same side interior angles are supplementary. You remember supplementary means their measures add up to 180. So looking at the picture, the same side interior angles would be angle 2 and angle 1. They're both on the right side of the transversal and they're both inside lines A and B. So this theorem tells me that if I add their measures, that I should get 180. Okay, now we're going to use those theorems in this section, and we're going to learn how to do the two-column proof. So we were doing the paragraph proofs in the last section, last chapter, just a little bit. And what we want to do now is learn to write them down in two columns. So we're still given, remember we talked about that the given information and the diagram were what we knew. What we're given, what we know. So sometimes it's written out, like in the given statement, A is parallel to B. And sometimes it's drawn into the picture, and you have to know what the picture is telling you. So here, remember the two red triangles are telling me that these two lines are parallel, A and B. So the diagram's telling me the same thing the given information did, but it's also numbering angles for me to use. What I'm trying to prove is angle 1 is congruent to angle 3. So that's what I must show. The two-column proof is going to be a way to just take some logical deductive steps to connect what I know or what I'm given to what I'm trying to show or what I'm trying to prove. The last statement is always going to be your proof statement, whatever that happens to be. The first statement is usually the given statement. You write down what you're given. I wouldn't write the word given, I would write A is parallel to B. And my reason would be that it was given. And in between those two things, so I've got to figure out how to get from A is parallel to B all the way down to the proof statement, which in this case is angle 1 is congruent to angle 3. Now along the way, as I write down these statements, I need to be able to write the reason that I can make that statement. So this is similar to what you have done in logic. If you took logic, we're having to use the different reasons to support our statement. Okay, we're going to look at a proof now. Okay. think I erased some of my writing over here. Where this should be too. Okay, so what we're going to try to do is we're going to try to prove theorem 3.1, which we said was the alternate interior angles theorem. I'm going to try to prove that angle 1 is congruent to angle 3, given what I have here in the picture and in the given statement. So the first thing that I'm going to do is I'm going to restate what they told me was given. I'm going to say A is parallel to B. And my reason is going to be given. So even if you don't know where to go with a proof and you can't get all of the answers at first, you should know how to get the very first statement and the very first reason as well. Now, I have the numbers written down. Most of the time you will not know how many steps it's going to take, so you'll number as you go. Alright, so I need to look at what I'm trying to prove and kind of think backwards. Sometimes that helps. So if I'm trying to prove that angle 1 is congruent to angle 3, I cannot use theorem 3.1, which tells me that alternate interior angles are congruent. I can't use that. So I have to use other things that I know from either other postulates or theorems, or from things that I've learned in other sections. So one thing that I can do is I can say angle 1 and angle 2 are congruent because they're corresponding angles, and we did have the corresponding angles postulate that told me that any corresponding angles are congruent. So remember, they're in the same position relative to the transversal and the line that it's intersecting. Angle 2 is to the right of the transversal, and angle 1 is also to the right of the transversal, and they're both above the lines that they're next to. So these two are corresponding angles. So I could say angle 1 is congruent to angle 2. And that's by the corresponding angles postulate. Now, I have these three different angles that I'm trying to eventually get to angle 1 is congruent to angle 3. So somehow I need to get angle 3 involved. Now what I'm hoping is it will also be somehow connected to either angle 2 or angle 1 as I'm going through, so that I can somehow say something about those. So right now I'm looking at angle 3, and I do see that angle 3 and angle 2 are vertical angles. We've talked about those before, and we know that vertical angles are congruent. So I could say angle 3 is congruent to angle 2 because vertical angles are congruent. So if you ever don't know the name of a theorem or a postulate, but you know what it says, you can just write it down like I did right there. Alright, so now we're almost there. We have angle 1 is congruent to angle 2, and we also have that angle 3 is congruent to angle 2. Since they're both congruent to the same angle, I can use either substitution or transitive property of congruence and say that angle 1 is congruent to angle 3. So I'm going to say the transitive property of congruence. And so that means that I'm done now because I got to my the statement I was trying to prove. Now as you go, it's not going to always seem very easy, because as you're watching me do the proof, then you can understand that it makes sense and why I'm saying the things I'm saying if you're following what I'm doing. But sometimes it's a little bit harder to plan it on your own. So the good thing to do is to try to work backwards from what you're trying to prove to what you're given. And if you have several angles and you're trying to get something like the angle 1 is congruent to angle 3, you need to look and see what else are they congruent to, or are they supplementary to something? Because we did have another theorem that said that if two angles were supplements of the same angles, and those angles had to be congruent. So there are some different things you can try, but sometimes it helps to try to plan from backwards to the front, to the top. Okay, so this is example 3. We're going to try another one. But first, in example 3, we're actually going to plan it out. And then we're going to write the statements and reasons. So, again, you don't normally know how many steps you're going to have. I've already done this problem, so I know how many steps I need. But normally you'll just number as you go. All right, so first let's look at our picture. We have two parallel lines, A and B. That's also written in our given statement. We have three angles, 1, 2, and 3. We're trying to prove that angle 1 and angle 2 are supplementary. Now again, I can't use the same side supplementary angles theorem, or same side interior angles theorem to say that they're supplementary. I have to prove this by using other things. However, I can use any of the other theorems or postulates that I'm not proving at the moment. So if I look at this and I want to say 1 and 2 are supplementary, then I think about the other things that we've talked about with supplementary angles. We know that if two angles are a linear pair, when you put the adjacent angles together, they form a straight line. Then I know that those two angles are supplementary. So that's getting angle 2 and angle 3 involved, but I still need to somehow connect 1 and either 2 or 3. So another thing that I could do then is I could recognize that angle 1 and angle 3 are corresponding angles. And remember, we had the corresponding angles postulate that said that those two angles are congruent. So that's a couple of different ways to get some things involved. So maybe I would plan something like to first say that measure of angle, or let's just say angle 2 and angle 3 are supplementary. Now I'm not really giving reasons for that right now, I'm just making my plan out. And then after that I might say angle 1 is congruent to angle 3. And then we know that if two angles are congruent, then they would be supplements of the same angle. So that would tell me that angle 2 and angle 1 are supplementary. It makes sense when you think about it. Let's just look at some numbers for a minute. Let's say angle 3 was 70 degrees, and angle 2 was 110 degrees. So 110 plus 70 equals 180. They're supplementary. If angle 1 and angle 3 are congruent, then angle 1 also has the measure 70 degrees, which means if you add 70 plus angle 2, which was 110, it's also going to give you 180. So those two are going to end up being supplementary. Sometimes when it's hard to think of this without angle measures, you can just make up some angle measures to help your mind think through it a little bit. Okay, so if this is my plan, then the next thing I'm going to do is go ahead and write down what those statements are going to be. So the first one is always going to be the statement that you're given. So A is parallel to B. And my reason will be what? Given. Okay, now we don't have to go in a completely the same order as my plan, but that's what I'm going to try to follow. So the first thing that I'm going to say is that the measure of angle 2 plus the measure of angle 3 equals 180. Okay, that's the linear pairs, definition of linear pair, or you could say the angle addition postulate, something like that. I'm going to say angle addition postulate. I think the linear pairs, when we talked about linear pairs, that was a kind of like a special case of the angle addition postulate. Okay, and then I'm going to try to bring in the next part that we said angle 1 is congruent to angle 3. But since we're talking about measures of angles, I'm just going to go ahead and use, say, measure of angle 1 equals measure of angle 3. And I'm going to say that's the reason for that is the corresponding angles postulate. Now you can start to abbreviate a little bit. You could put CORR period and then the angles postulates, because after a while it gets hard sometimes to write all this in. So just make sure your abbreviations are something that I will understand. All right, now because we know measure of angle 1 equals measure of angle 3, I can use substitution, and anywhere I see measure of angle 3, I can put measure of angle 1 instead. So I'm going to fill in, so I've got measure of angle 2 plus, this is where I'm going to use the substitution. Instead of measure of angle 3, I'm going to put in measure of angle 1. So all I did was take measure of angle 1 and put it in place of measure of angle 3. So that's my substitution. And this time you can't use transitive because you're actually taking what measure of angle 3 is equal to and putting it into a different equation. Okay, now I have measure of angle 2 plus measure of angle 1 equals 180. What I'm hoping is to write down what the statement is that I was trying to prove, which is angle 1 and angle 2 are supplementary. I can do that because measure of angle 2 plus measure of angle 1 equals 180 is the definition of supplementary. So sometimes we use definitions as well as postulates and properties. Okay, these proofs are a little bit difficult to start with. After a while, we're going to practice these so much and use the same kind of reasoning so much that you're going to be able to come up with ideas for how to get your proof statement a lot easier. Okay, the last two examples in the book and that we're looking at right now are actually finding measures of angles. So we're using those theorems to and some information we're given to try to find the measures of different angles on the picture. Okay, so first let's look at the diagram and make sure we understand what they're telling us. So this time we have 4 lines, A, B, C, and D. C and D both have the triangle, red triangle arrowheads that are telling me those two are parallel. And A and B also have red triangle arrowheads. Now your book just puts one each because they're going different directions, but sometimes you will see one set of arrowheads to show that C and D are parallel, and then sometimes they will put 2 arrowheads on the other pair of lines that are parallel so that you'll know which ones they're talking about. So if you see the 2 arrowheads, that just is helping you identify which 2 are parallel and which the single ones would be parallel. Okay, so this picture is a little bit tricky because we can actually consider any of these lines to be transversals because they're intersecting, like line C is intersecting parallel lines A and B. Line D is also intersecting parallel lines A and B. So each one of those could be looked at as a transversal, or we could look the other way and say, well, C and D are parallel, so A could be a transversal, or B could be a transversal. Okay, so the first thing that we notice too is that they've given us the measure of one angle, angle 50. This is 50-degree angle. That's the one thing I know that's going to help me find the measures of all the other angles. So the first thing they asked me to find is the measure of angle 1. Well, I need to think about the postulates and theorems we've had. So the first one was corresponding angles are congruent. The second one was that alternate interior angles are congruent. And the last one was that same side interior angles are supplementary. So those are the three things I'm going to be using. Somehow I need to find the measure of angle 1. Let me change colors. I want to find the measure of angle 1. Angle 1 is below line B, and it's to the right of the transversal, in this case is line C. And the angle that's marked 50 degrees is also below line A and to the right of transversal C. So these two angles are corresponding angles, and we know that corresponding angles are congruent. So the measure of angle 1 is 50 degrees. And my reasoning, here I asked why, justify your answers. The reasoning would be the corresponding angles postulate. Okay. Now, the next one is measure of angle 2 that we're looking for. So now I'm looking here. Well, if I think of C and D as my parallel lines and A as my transversal, then angle 2 and the angle marked 50 degrees are on the same side of the transversal, and they're inside lines C and D, so they're same side interior angles. That means that the measure of angle 2 plus 50 degrees has to equal 180 degrees because same side interior angles are supplementary. So that would mean if I subtracted 50 from both sides, I would get measure of angle 2 is equal to 130 degrees. And that's because of same side interior angles theorem. Excuse me. Okay, why don't you pause and try to find the rest of the angles. Also, make sure you know the reason that you're giving the number you're giving. And then come back and see if you got the answers right. Okay. Excuse me. Measure of angle 3 is the next one. I'm going to compare that to the measure of angle 2 because those are corresponding angles. They're both below line A or line B, and they're to the left of line D. So those are corresponding. They're in the same position relative to the line D and then the line that they're next to, either A or B. So corresponding angles are the same measure, which means that angle 3 will also be 130 degrees. Why did that change? Yeah. Okay. Measure of angle 4. I think I moved my line, didn't I? No. No. I'm trying to highlight that line, but I can't do it. I can't move the line back. Well, keep trying. Okay, well, imagine that line's in the right place. I'll just put another one in. I was going to try to delete that, but I can't. Okay, so line Angle 4 is across from angle 3, or, so that could be a vertical angle with angle 3, or you could look at angle 2 and angle 4, and those would be alternate interior angles. Either way, angle 4 is going to have the same measure as both 2 and 3. So that's going to be 130 degrees. So if I was trying to justify my answer, I would either say vertical angle with angle 3, or I could say alternate interior angles with angle 2. Okay, either way. It's funny how when you look at a diagram, sometimes you will see it one way and somebody else will see it a different way, and you'll both get the right answer, but you just went about it in a different way. Alright, now measure of angle 5. Let's see. It's not a same side interior, but it is an alternate interior angle with the angle marked 50, or it's a vertical angle with angle 1. So however you see that, those should be the same measures as either 1 or 50. Okay, so again, that would be the same reasons as the one right above it, except the different angles that it's vertical with or alternate interior angles with. All right, measure of angle 6 is here. A couple of ways you can get this one. The easiest one is to look at angle 6 and angle 2 and realize that those two together form a straight line, so they're a linear pair, which means angle 2 plus angle 6 has to equal 180. Angle 2 was 130, which means angle 6 would have to be 50. Now, another way of looking at it is if I look at C and D as my parallel lines and A as my transversal, then angle 6 and angle 50 are alternate interior angles. They're on opposite sides of the transversal A, but they're on the inside of the two lines C and D. So either way you want to think about that. Whichever way you think about it, it should end up being a 50-degree angle. So either alternate interior angles or linear pair. All right, measure of angle 7. Again, if I'm thinking of C and D as my parallel lines and A as my transversal, I can think of angle 2 and angle 7 as alternate interior angles. Or I could think of angle 7 and the 50-degree angle as linear pair, which makes them supplementary. So either way, that should end up being 130 degrees. So again, it's just like the reasoning before. And then finally, measure of angle 8. Either I will look at it as vertical angles with the angle that's marked 50, or I will think of angle 8 and angle 7 as being linear pairs, and I know they're supplementary. So measure of angle 7 was 130. 130 plus 50 would give me 180. So either way I think of it, that has to be 50 degrees. So this is either vertical angles or the linear pair. Okay. So sometimes you're going to have these pictures and you're going to have to go through one by one until you find all of the angle measures. All right, example 5 is a figure that doesn't look exactly like what we've been doing so far. They want you to find the values of x and y. So I'm looking at to see if there's anything similar to what we've been doing. And so by the diagram, I see that I have the two red arrowheads that are telling me that this line and this side of the triangle are parallel lines. So I've got to look and see if those are parallel lines, where are my transversals? And how do I use all the things that I've learned so far? So if I extend those lines a little bit to make sure I can see it. Okay, these two are my parallel lines. The transversal, it could be in several different places, but let's see which one helps us the most. We're trying to find x and y. We're given 70. So if I think of the bottom line as the transversal that's going through, then in relation to these parallel lines here and here, where the transversal comes through, and this angle that's marked 70 and this angle that's marked x are corresponding angles. They're both below the line that's given, so let's just name these lines and make it easier. So 70 degrees is below line A, and on the top of the transversal we'll call T, and then X is below B, line B, and above line T. So those are corresponding angles, so that tells me that X has to equal 70 degrees. Okay, somehow we have to find Y. So if I look at what's left, this angle here is a straight angle. It's 180 degrees from one side all the way around. The three angles that make that up are X and Y and 50 degrees. So all three of those added up should give me 180. I know what measure of angle X is. It's 70. So that means 70 plus 50 is 120, plus the measure of angle Y equals 180. And then I would subtract 120 from both sides, and I would get measure of angle Y equals 60 degrees. So in this case, that's the only two things I had to find were the X and the Y. Now I want you to look at the check understanding number 5 in your book or on this screen, and I want you to pause and try and see if you can figure out what X and Y are in this diagram, and also find the measures of the angles. Okay, so hopefully you worked that out and you're back. Alright, so we're looking at, different color. We're looking at this top side as being one of the parallel lines and the bottom side's another. Didn't mean to do that. Keep moving it. Dadgummit. I'm just going to do it out here. Alright, so these are my parallel lines that are drawn in. The line that's on the left side of the trapezoid that has a right angle marked there could be one of the transversals. The other side that's more slanted also is a transversal. So if I look at first the side with the right angle, then the 2x and this 90-degree angle are on the same side of the transversal, which we said was this side, or it could be this one over here. So I encourage you to go ahead and extend your lines. It helps you to see how it's relating to what we've been doing. Anyway, these two are on the same side of the transversal. They're both on the right, and they're inside the two parallel lines. So these would be same side interior angles. That tells me that they have to be supplementary. So 2x plus 90 has to equal 180. If I subtract 90 from both sides, I get 2x equals 90. And then divide by 2. I get x equals 45. Alright, so that's part of my answer. Now on the other transversal, I also have y and y minus 50, those two angles are on the left side of the transversal, but they're also inside the parallel line. So these two are also same side supplementary angles. So that means if I add those up, y plus y minus 50, that should equal 180. I'm going to combine like terms and have 2y minus 50 equals 180. And then I'll add 50 to both sides. So I get 2y equals 230. And then I just need to divide by 2. I end up with y equals 115. All right, those are two parts of my answer, but they also wanted me to find the measures of the angles. So I'm going to write those in purple up here in the shape. If I know that x is 45, then 2 times x would be 90. Okay, y we said was 115. So y minus 50 would be the other angle. That would be 65 degrees. Now I can double check myself and make sure that 115 plus 65 does equal 180, which it does, to make sure, because these should be supplementary. Okay, that's the end of this video. I hope that you take time to work through the problems and try to do the proofs as much as you can, and we will talk more about those when we meet again on Thursday. Let's see, the date would be October 11th. So you will have from now till then to get this work done. I'd go ahead and do it now before your break. And I hope you have a good break.